Hello everyone, welcome to Gates. Myself Kafipriya and this is Sherina. Today Sherina HMT subject la rendu topics பத்தி explain பண்ண போறாங்க. First Newton's law of cooling, next Stefan Boltzman law.
So firstly we will be seeing about Newton's law of cooling. So we can consider a body. So when you consider this body, in this convective heat transfer occurs in this body, and the temperature of the air is T alpha, and the temperature of the surface of this body is TW, that is the wall temperature of this body. So according to Newton's law of cooling, firstly the heat transfer rate Q is directly proportional to area. This is the first concept. The second one is heat transfer rate is directly proportional to the change in temperature. So these are the two constants that we have considered. So when we write it in the same equation, Q is directly proportional to A delta T. In order to remove this proportionality constant, we introduce a small h into this, that is Q is equal to H A delta T. So when we see what this H is, this H is convective heat transfer rate. So H is small h is convective heat transfer rate, and the unit for this is watt per meter square Kelvin. So this is all about Newton's law of cooling. The next concept that we are going to see is Stefan Boltzman law. The Stefan Boltzman law is based on radiation, that is Stefan Boltzman law of radiation. So according to Stefan Boltzman law of radiation, it states that when a black body emits radiation, that is in unit area and unit time, it is equal to the fourth power of its absolute temperature. It's equal to the fourth power of its absolute temperature. So the emission in the radiation emission in the black body in under unit unit area and unit time, it will be equal to the fourth power of the absolute temperature. We introduce a constant here, which is, so here EB is directly proportional to T to the power 4 according to Stefan Boltzmann's law. When we see a black body, it is not necessary that a black body has to be black, but anything that absorbs the complete temperature, that is called as a black body. It can be either ice also an example of black body. So when we come back to this equation, E suffix B is directly proportional to temperature power 4. So in order to remove this proportionality constant, we introduced sigma T power 4. So this sigma is Stefan Boltzmann constant. The value for this sigma is 5.67 into 10 to the power 8 watt per meter square Kelvin power 4. So this is all about Stefan Boltzmann law. Here I missed a statement, that is after writing this equation, since we are considering two temperatures, that is outside temperature of the air and the wall temperature of the surface of this, we write it as Q is equal to HA. For delta T, it is TW minus T alpha.
Okay, today video la Newton's law of cooling and Stefan Boltzman law பத்தி அழகா எக்ஸ்பிளைன் பண்ணாங்க. அது அழகா எக்ஸ்பிளைன் பண்ண சரியா.
Thank you.